we are very excited to support the Passive House Accelerator. Most of you might and should already know us for our Passive House materials, including Proclimus and Tallow, Esconvana. Another supporter of the accelerator is Lamelux, our glass roofs and flat roof skylight systems. And furthermore, we have Gutex, Lunos, Truol heat recovery, and other materials available for you. But today we're going to focus on our new partnership that we've made with Brink from the Netherlands, and we're very excited to bring these units to Canada and the United States. Of course, everybody knows we spend a lot of time in our own homes, and even more so since the pandemic started. And since the pandemic started, we've also realized the need for fresh air and continued air changes inside your house, inside your airtight envelope, are very, very important to stay healthy, to stay happy, and to thrive. So we are so excited to be providing these central systems now in the United States. We've done a couple of pilot projects in the last years, and now we are ready to receive our first larger shipment from Brink in the Netherlands. This is their new building, built in 2014. They outgrew their prior location. They're very committed to sustainability, so they have a huge solar array on the production facility. They have filtered fresh air, of course, with heat recovery for all their employees, and they're leading by example. So this is a great low carbon efficient building where they produce and design these units. So Brink has 40 years of export experience, experience in HRVs. They work with ventilation since 1964, but not with heat recovery that long. They have over 250 employees, and they have a good revenue, but they also like to invest their profits into better products. So R&D, which is dear to our heart, we like to work with innovators in this space. So high efficiency heat recovery in the homes. So they're market leaders in Europe, and best specifications of their machines due to the state-of-the-art technology. As I said, they invest a lot in R&D. Their constant airflow, where they were the first to implement that, and so with the new units, they have taken another step in that progression. They pride themselves in a good price and quality relationship, and are reliable and loyal. I was just speaking to Arthur from Brink an hour ago. He was in Spain, and it's great to have this collaboration with them. We continue to optimize the systems, even though we just started to bring them in. We're making small tweaks to our next productions. So the history of Brink. So in 1984, this produced the first Dutch heat recovery unit. This was followed by the first counterflow heat exchanger in 1996 to, as you might all know, to up the efficiency. Not a cross-flow heat exchanger, but a counterflow heat exchanger really makes a big difference and allow you to get to that 80 or 90% efficiency of heat recovery. Then a constant flow integration was integrated into the Renovent. Then the Renovent got a display. They further improved it in 2011. And so then after about 20 years of producing the Renovent, it was time for really the next generation of heat recovery machines. And so we are proud to produce these FLAIR units right now for the United States and Canada. And this is taking another step in performance, another step in efficiency, and another step in becoming quiet. So, of course, we looked for a unit with Passive House certification, which this unit is one of the most efficient ones. Of course, they have all the other European certifications, which is very nice and dandy, but of course, everything else is different in the United States. Our air is different, our fires are different, so we need to get tested to UL for the United States and to CSA for Canada, and that's in process. We expect that to be done early 2023, so then there shouldn't be any questions anymore for authorities having jurisdictions, also known as your building inspector, about using these units in your projects. So the FLAIR. You can see this design is quite modern. It features a couple of great steps that they took. They increased the heat recovery efficiency from the mid 80s to the high 80s or low 90s. It has very user-friendly operation. It actually has a touch display on the front that you can use to control and also change the settings on your unit. It's industry leading. Again, that aligns with Brink's legacy and also their commitment to continue improvement in R&D investments. One great thing is that it only needs one tool to be maintained. One T15 screwdriver is all you need to take the unit apart and put it back together. Very, very nice. And so this is meant to satisfy both the installer and the homeowner's needs and exceed their expectations. A great plus point of this unit, especially in smaller quarters or in any house, is that it's a pretty compact unit, which is nice. Of course, you can have more room to work around it in your mechanical space, but everybody knows the mechanical spaces are always designed too small. Don't do that. Have enough space for your mechanicals, but if it is small, this unit might make it a little bit easier. It's also very light, just 81 pounds or 37 kilograms, and it's normally supplied with the 4.0 standard, which means supply and exhaust are connected on top. More about that later. It's the most efficient HRV ERV option with a PHI efficiency of up to 91%. And if you choose the ERV, the humidity recovery is up to 77%. So all very, very high and industry leading numbers. So here are a quick overview where you can see that the unit, the FLAIR, is indeed the most compact of all the European machines, and with high efficiency machines. And you can also see that it's one of the lightest one around, which is also, of course, nice, because you don't need that many people to install it, or etc. So even at maximum flow, the noise level in your rooms can be, of course, with the right manifolds and or noise reducers, be kept easily under 20 or 25 decibels on boost, which is, of course, very, very important for people to not be bothered by the heat recovery machines. Of course, it's kind of interesting that some people won't believe that it's on. So sometimes a little noise on the boost is appreciated, but I don't think you should actually try to design that in. You should design it out. Everything is on board as a standard with the Brink. So the preheater is always included. So is the bypass, the summer or shoulder season bypass. And as well, the connectors for CO2, relative humidity, or boost switches integration is native even on the standard machine. As you can see here, all in gray around the heat recovery core and encapsulating the fans is highly insulative housing. So it's completely continuous, seamless insulation. And then it's actually housed in a metal enclosure, which of course is very durable. So you don't get any dings or damage into your insulation. It's not a fragile machine. Access is from the front. All major components are replaceable. Of course, they shouldn't have to be replaced, but if, God forbid, something happens, they can be swapped out. There's no pressure tubes to help with the flow equalization. It's actually done with a vane anemometer. Again, one screwdriver. Disassembly time is about 5 minutes, so very fast. Again, shouldn't never need that. And the foam part stays intact. As I said, it's one airtight, continuous gray box that houses everything. Here a little bit overview from the other side. So you can see this is the left-hand unit. So you can see the house connections, the connections to the inside of to the interior are on the left side. So the bypass is also on the left side, which allows you to bypass the heat recovery core when the outside air is colder than the inside temperature and you want to have some free cooling. The preheater is on the right. Now fans and filters complete the unit. The heat exchanger. So the HRV heat exchanger is produced by Brink themselves in-house. these counterflow heat exchangers have a large surface area, which again increase their efficiency. Lower pressure drops, pressure loss, and very high thermal efficiency. And it's made from PETG, which is a recyclable material, also known as your plastic bottom material. There's guiding airtight sleeves where the core slides into to, of course, prevent any cross-contamination from the air flows and make for a secure fit in the unit. These high efficiency EC fans are, of course, the heart of the machine. The radial fan, backward curved, are both for in and out, and the spare part, again, should never be needed, can be completely easy changed in and out of the machine without screws, so very easily to get this into the machine. And this is the magic of this fan, is the constant flow vane anemometer. Ultra precise and fast flow measurement, so we can be assured that in and outgoing airflows, exhaust and supply, are equal. They're balanced, which of course is important in a passive house, because we want to make sure that the amount in and the amount of air out are the same. The bypass will allow for up to 100% bypass for this shoulder season free nighttime cooling. Not the European summer nighttime cooling, but only available, or should only be used, of course, in the settings when it's colder outside than inside, but you do want to cool the house. It has guiding vanes for equal flow over the total heat exchanger, and a robust design with a maintenance-free DC motor. Intelligent frost control, new aerodynamic design with a larger surface. Think cooling ribs, but of course these are heating ribs. Double safety, and this aerodynamic design again assures complete use of the heat exchanger, or maximum extraction of the heat. The dry siphon or trap, it's included with every unit. HRV, ERV, doesn't matter. You get it in the box anyways. And the encapsulated ball prevents backflow of air, even though you should have a second disconnect from your drainage system anyways. On the front, here we have our full color screen. As you can see, it's set on low on this screen. You can also set it on medium, high, and then on a boost switch. There's a clear menu structure, and everything can actually be controlled from the screen. Even your CO2 boost or your RH control, that can all be done with this. So it's a four-way speed switch built into the unit. Of course, you can have switches elsewhere in the house that you can also use to control the unit, as well as an app if you connect the unit to the internet. So the standard PCB has one kind of like internet connection, the RJ12 switch, where the 4-position switch can be located elsewhere in the house, or a boost switch can be attached. Air control, master slave service tool, and the CO2 monitoring can also be attached here in these colored coded slots. And 24-volt output for external accessories. Then on the flip side, if you do want to connect to the internet, one will have to order it with a plus PCB. So then the app control and the Brink home portal will be accessible, and we can do other things with analog inputs, 0 to 10 volt for building management systems, BMS, as well as a post heater and other accessories. Very happy with this, to report this. This is, I think, a great innovation for that much more appliance manufacturers should aspire to. 99% cardboard packaging. No extra foams, no extra nonsense. So they made sure that the cardboard protects units sufficiently. You can actually see that the duct covers protect connections during transport and installation. So that's here on the right-hand photos. You can see both duct ports, or all 4 duct ports are covered by this cardboard protection. So quick specs. 29 by 25 by 22, 6-inch duct connectors on the FLAIR 325, and up to 191 CFM. Heat recovery 92.5% by European norms and 91 by PHI. The FLAIR 400, same size in dimensions, but up to 235 CFM. And the duct connectors take a little step up to the 7-inch connectors, or the 180 millimeters. Heat recovery, a little bit lower in PHI, 89%. So what's included in the box? Of course, the heat recovery machine, the wall bracket, or that metal bracket you saw on top of the box, bumpers and rubber strips to even isolate the vibrations even more, the dry siphon, and the manual. So here we show the right hand 4.0 version. So the right hand is the inside connections to the house. And then we go into the peripherals. What else do we need? So the FLAIR 325 has 10-port manifolds. So you can see a little bit smaller house. Of course, you shouldn't need 15 duct connections. So you get 10 duct connections. But for the larger unit, we got a 15-port manifold. But for a 3,000 or 3,500 or 4,000 square foot house should be sufficient, unless you have many bathrooms. You know, if you have 6, 7 bathrooms, maybe you need a second manifold. Rigid silencers will also be supplied by us. But as you can see, the manifold actually has sound insulation here on the picture on the right, built in. So that this, in a lot of cases, will take any fan or air noise out of your ductwork to start. Duct and register boxes that we'll be supplying will have 2- and 3-port register boxes. If you need a little bit of higher exhaust flow, mostly in the kitchen, that can be done with a 3-port. Otherwise, the regular 2-port register boxes are in metal and sufficient. And then we'll both be supplying EU semi-rigid ducts, as well as the 3-inch flex ducts. So if you need UL, of course, you need the flex duct. If you want a little more robust duct, then the semi-rigid duct is proven pretty popular. For your other side of the register box, metal supply and exhaust manifolds can be used, or diffusers can be used. And we also have a special kitchen exhaust with a filter. So those are the basic design. And then if you want to take a step up, we have the 5-inch square design, which is very modern, can even be painted to almost completely disappear in the background, as you see here in these both bathroom photos from a pilot project. Exterior connections, there's a proprietary insulated duct system available that you see here on the left, and on the right, the wall outlet. We also will be supplying roof outlets for both pitch and flat roofs. So stay tuned for that, for more developments on that side. So here we've been enjoying filtered fresh air at our office in Brooklyn since our annual meeting. We felt in January, where we for the first time got people back together again, that we did need a continuous supply of fresh air and also exhaust of pollutants, i.e. potential virus particles. So we installed the Brink in our unit, and actually have been enjoying this quite a bit. And we actually noticed it quite well if it's not working as it should. So here you can see what kind of difference this makes in Brooklyn. We're close to 4th Avenue, which is a truck route. And you can see that after 59 days in New York City, that's the pollution we have avoided from breathing into our lungs. So that's pretty nice. On the left, you know, there's still some dust being produced or tracked into our space as well. So that we're protecting the filter, the machine itself, by these MERV 788 filters. But the MERV 13 filters, of course, are at the heart of the machine and filtering out this dirt. The CO2 sensor, that is actually very, very productive, both to have the unit run as it should. It actually speeds up quite a bit when we have 12 to 15 people in our space, and it almost maxes out. But you can see we can easily keep the CO2 below 1000 ppm, which is, you know, the healthy level for people to stay productive. We can actually see here that when people go to lunch, which is kind of interesting, you know, we have a small dip in the middle of the day, and you can also see it comes all the way down to about 400 ppm when people are not there. We're a little confused. Well, this was actually a weekend. Well, the ppms never got below 500, so we don't know what happened either on the inside or the outside of our space that caused that. So it's a little bit Big Brother, but it's fun to look at this data and these outputs that you get on the Brink home website. Hardwired boot switches. You know, you can use a plain old Levitron or other US switch to put the unit in boost. So this is a very affordable solution to boost your unit either from your bathroom or your kitchen. And the standard unit allows that to be wired in quite simply. And we can also do an RH-based boost, where you would either put a sensor in the manifold, or actually in the exhaust duct from your primary bathroom, and then the unit will sense an uptick in RH, i.e., somebody taking a shower, and it will start ramping up until that shower humidity has been exhausted. So also a nice automatic way to control the unit without a lot of difficulty in programming. So delivery and installation. Have ordered from us before. We will plan for the Brink to do a regional rollout and supply of service. So we're starting close to a home base in and around New York City, but then we'll start stocking in our warehouses throughout North America, which will facilitate faster and cheaper delivery. And then everywhere we'll have the great support and experiences you've come to expect from 475, including installation support and commissioning. So we'll be putting a questionnaire into the chat. So if you are interested in these Brink machines, and we would like to hear from you, as that our first order is on the way, but some guidance and extra feedback from the market is always appreciated, and also know to see where the demand is the biggest and our passive house is growing the fastest. So HRV versus ERV, of course, the HRV will be less than $3,000, while the ERV will be slightly over. This is both a financial decision, but of course, some climates really need the ERV, and then other preferences between metal, EU, or UL ducts. That takes us to the end of the presentation. I hope you have enjoyed it, and I would think there would be a couple of questions. So, Zach?
Yes, fantastic, Floris. Thank you. There are several questions, and thank you everyone for being here. We have 180 people taking in this presentation, which is exciting. I think everyone's really excited to see this new option available. So I think up first for the first question is Susan Below. So Susan, can you ask your question?
Oh, thank you very much for the wonderful presentation. You said you're going to release in Canada, so I'm sure you've probably thought about how extremely cold it is there. I'm in Montana, not too far south from there. Is there a temperature at which this will not work?
No, so the unit will have its own included preheater, which does allow the unit to stay and keep the comfort temperatures inside of the house at a good level, and also prevents freezing of the core in case of using an HRV. If you get to the really frigid temperatures, sometimes an additional preheater will be required. But we're talking, I think in Montana that's not necessary, but we have to look at your specific location then, because maybe if you're high up in the mountains, it could be, you're talking going to minus 30 C or also close to minus 30 F in that case.
Great, thank you. Thanks, Susan. Next up is Tim Ian.
Hey, how's it going? So similar question. I was just curious about climate zone 6 and 7. I think you covered that. So because we've seen that sometimes we need an external preheater. I'm also curious about ground source preheating. Maybe you have a word on that. And then the last but not least, I'm curious if the machine is staged. So does it still revolve around like a level 1, 2, 3, or is it actually variable fan speed based on air quality if you give it one of those CO2 sensors, for instance? So do you have to commit to these individual speeds, or is it just does what it needs to do at, speed not important, air quality important? Thank you.
Yeah. So I think we kind of answered the preheater question already. A glycol or a ground loop can be integrated. We currently are, we don't have the plug and play solution for that. We know it exists, and we're working with somebody on that, but it's not in phase 1, so to speak. It's a nice add-on. I definitely agree with that. And then regarding the CO2 sensor, yes, it actually you can indicate at which ppm of CO2 you want the unit to start ramping up. And so actually in our office we have it kind of set at a funny setting because your away setting is very low. It's 50 CFM, 35 cubic meter, 50 cubic meters, so 35 CFM. So we actually have set our setting 2 is at 55, which is the lowest you're allowed to set it. And then our setting 3, our boost setting is at 350, so about 200 CFM. And in between it will actually ramp up, because it's just seeing the CO2 increase, and they see in the office, we have very productive people apparently, because the CO2 goes up very, very fast, but then the flow rate also increases very, very fast between those 2 set points, and it's gradual. So yes, so normally the settings are fixed between 1, 2, and 3, but with this CO2 sensor, it will ramp it.
Great, thanks, Tim. Next is Michael Martins.
Hi there. Question for you guys. Does this come with carbon filters, or do we have to pre-scrub the air in heavy areas where there's lots of smoke and forest fire zones in Western Canada these days?
Yeah, the carbon filter is an option indeed inside the machine. So then you don't have to. So you would change out the regular MERV 13 for a carbon filter.
Can you double them up, have a MERV filter and a carbon filter? Is that possible?
Yeah, then you would have to do it with an external filter box.
Okay.
Because otherwise it won't fit in the machine.
Great. Is that good? Is that good, Michael?
Yeah, that's good. Thanks.
Okay, fantastic. Next up is Kyle Mocht.
Hey, everybody. I was just curious about makeup air. I know there's not many options in the United States to have makeup air integrated into a ventilation system, and I was wondering if this has any opportunities for that, or if there might be in the future.
So for the only thing we can do with these machines, because it normally runs balanced, but I'm going to assume you're asking about a kitchen disbalance.
Yeah, kitchen,
yeah.
Or usually it's kitchen for us that we're trying to develop a makeup air system for, and it's usually a few grand, and it'd be nice if it was all integrated. Yeah,
so it's with reasonable sized kitchen exhaust that this balance in the machine can handle with it, but a reasonable size is not much more than your code minimum intermittent exhaust flow. If you are looking for the 400 to 600 CFM, then it's not going to work because that's just the machine itself does only 235, right? So that it's too much of too much flow to come through the pipes pretty much, and you will have to do a separate makeup air solution.
Good to know. Thank you.
Great, thank you, Kyle. Next up is Lindsay Klein.
Thanks, Zach. And thank you very much for this. I wanted to ask, since 475 is so great at service, if there's going to be a service component for homeowners once they have been given their home, their passive house. In other words, ongoing maintenance, regular, yearly, potential way to sign up.
Right. So yeah, that's why we're saying we're rolling this out locally. And so the service component will be location specific. So that's we are working on an additional 5-year warranty option, where you also get filters. And it's interesting for you to hear that there's a demand. Filter changing is pretty easy, but there's other things that could go wrong. So we definitely like to pursue that.
Yeah, I mean,
it will be location based.
Yeah, you show how interchangeable all these parts are, but I think
Right.
it's fine for us to be looking at all this, but for a homeowner, I like to encourage homeowners to sign on to a service agreement.
Sure.
And leave them knowing they're in good hands.
Right. No, and that's it should be, you shouldn't have to, the gray door, you should be able to open and change the filters. Most people. But you shouldn't open more than the gray door. I agree with that. And that's where a service would be very good, but it will be location specific, definitely in the first year or two.
Great. Thanks, Lindsay. Up next is Denise Cecilmus. I hope I pronounced that correctly.
Pretty good. My question, hi Floris, thanks for the presentation, is about if you're eventually planning on scaling these up for higher capacity units for, say, small multifamily in the future.
So, and how big would that flow be, if I may counter the question?
I mean, I guess let's see, like imagine if you had like a 2 or 3 family in a stack, for example.
Sure. Yeah.
Not necessarily like the huge.
Right. No, that's why I'm asking. So there is a FLAIR 600 which is rolling out in Europe right now. So we're going to start with the 325 and the 400, but our intention is to bring that 600 and also the smaller unit, the 200 or the 225. Into North America, but that not right now, but hopefully within a year and a half, something like that.
Thanks, Denise. Okay, so Meredith Randolph, you're next.
Sorry, my question was answered.
Okay, great. Thanks, Meredith.
Okay.
So that means that Al Horvath, we're ready for you. Al, I see you in the meeting, so I'll give you another moment or two. But I can read your question. So this is he says another preheater question. Maybe this has already been addressed, but so it's for -25C design temp in Canadian prairies.
Yeah, so that's about that point, with Tim and talking about then where you might need a secondary preheater or a ground loop.
Cool. All right. So sorry, Tully, you may be surprised that you are up next, but you're up next. So Tully Gallagher, can you ask your question?
Yeah. Thanks, Floris. Appreciate the info. Do you know what's the size of the preheater in kilowatts? Is it different for the 325 and the 400, or are they the same?
I don't know that on the top of my head. I must say, I don't think they're that different, but I need to look it up.
Okay. All right. Thanks.
Okay, great. Thanks, Tully. Tomas Stitch.
Yeah. Hey, everyone. My question was answered. It was just the maximum temperature for the preheater, what it can handle. And it was, what was it, 25 minus Celsius?
Approximately, yeah.
Okay.
Yeah,
that's all.
depends on the duration and things like that, Yeah.
All right. Thanks.
Great, thank you. So next up is Kelly Fordyce or Fortis.
Hi, I'm just trying to get an understanding of the defrost strategy. Do you have a cold note summary of that?
So the defrost strategy is to not have defrost, which means the preheater makes sure that no frost occurs in the core by preheating the incoming air which is of course in the other sense slightly inefficient, because now that heat you put into the incoming air will be heat exchanged out of the unit by preventing frost into the outgoing airstream. But that's the only way to prevent freezing of the core at colder temperatures. So there's no recirculation of air ever.
Great. Thanks, Kelly. Okay, Bill Levine, you're up.
Oh, thanks. My question's about the replaceability and cost of the filters. Are they very, very specific to these machines, or if Brink disappears from the North American market, will people still be able to source some kind of filter? Thanks.
Yeah, sure. Yeah, there is specific filters for these machines. We are also, and Brink has produced this, there is a filter housing that we are thinking about bringing in, where you can actually put other filter fabric into the filter. The downside of that is that it's not you can't put a pleated filter into that, so you will lose a little bit of filter efficiency by using that setup, compared to the MERV 13, which is a very nice pleated filter with low pressure drop and good filtration.
Excellent. Thanks, Bill. So next up is Hans. Hans, I think you asked about CSA certification, and Johnny answered that yes, both CSA and UL are underway. Did you want to follow up, or are you good?
No, I'm good.
Okay.
I did
thanks,
have
Hans.
another question about the CO2 sensor.
Oh yeah, fire away.
Yeah, whether or not that's an external one, which measures CO2 in the room, or if it measures it in the return air stream.
So you can see here actually on the photo that I'm showing right now, in that red circle, we didn't, since we work in one big office space, it doesn't really matter where we put it, because the air equals out. But yeah, you can put it in any room. It needs 4 wires, so 18-4. If you're an electrician, you should know what that is. It's all you need to bring from the unit to the CO2 sensor.
Cool. Awesome. Thanks.
Great. Thanks, Hans. Next is Nicholas Petrie.
Sorry, my question was fairly basic. I think a few other people have already asked it. By the way, thank you for a great presentation. The 325 and the 400 units, I was just wondering what their approximate price was for the units in Canadian dollars. You mentioned 3,000, but didn't know which unit that was for, and if that was American dollars or Canadian dollars. And then the other aspect is, how much do the filters run? How much do the ducts run?
So yeah, the Canadian price will for the HRV will be slightly. Our intention is to have it slightly below 4,000 Canadian.
Okay. For which?
For the HRV, the 325 HRV.
Perfect.
And then the ERV will be about. I have to do the math in my head, because we haven't published this ERV price for Canada yet, but it should be hopefully under 5,000.
Okay.
And then the same thing for the ducts. It's in process. They're almost underway. They're almost in the container, but we haven't completely finalized that pricing yet. So that will come out pretty soon.
All right. Thanks, Nicholas. Ken Connolly, I see your hand is raised. Do you have a question?
Yes, just wondering when the products will actually be available in the Vancouver market in Canada, so on the West Coast. And then how would we proceed to get a quotation on the complete system? Do you want us to send plans, or how are we to establish a parts list and so on?
So we are bringing our first container into the East Coast of the United States at the moment. We will start to add before the end of the year on the US website a request a quote page, and also put some basic pricing on there, so you're not completely blind, because we like to be pretty transparent in that sense. And then we'll emulate that within 3 to 6 months on the Canadian website as well. So then that available, the quote and some basic pricing will be shown on the Canadian website, and then you can reach out to us to get a complete system quote.
Thanks, Ken. Okay, Ian Small.
Hey, Zach. Thanks, Floris.
Hey.
I was just wondering, you mentioned the relative humidity center and they would put in boost mode. There's no zones in this machine?
Well, zones would rely on your ductwork, correct? So that's so normally the setup is that you have supply into living spaces, bedrooms, living rooms, and exhaust out of bathrooms and kitchens. So the entire house will get fresh air everywhere. Somebody will ask about this because there is actually Brink has a system where they can actually direct based on CO2 readings in which site gets priority, the primary bedroom or the living room. But we're not. We have no intention to bring that in the next couple of years because we think it's too complicated.
Okay, great. Thanks, Ian. Tomas.
He's a. What kind of ducts will come with the unit? Are they round, oval, flexible?
So we intend to have both these available. So this is the semi-rigid European ducts and the 3-inch US UL listed flex duct.
And no oval ones with lower height?
No.
Okay. All right. Thanks.
Great. Thanks, Tomas. Tully.
Yeah, what's the depth of that diffuser box that you have shown in there, Floris?
Oh, it's less than 3.5. It's
hey, all right.
Yeah. I know why you're asking, and we've thought about this. So it will fit in a 2x4 wall. Although, the ducts, 75 millimeters, 3 inches. It's still tough to get it through a bottom plate, but it's possible.
Yep. Nope. I've done it before, but 3.5 deep is much better than 4 1/4.
Yeah, I know. It's a struggle, but it fits.
Thank you.
Patricia Partridge, I think we missed you before.
Yeah, hi, thank you.
Hi.
I'm just beginning to learn about these things. I'm an architect, so I figure I should know something. So I wondered if you could describe, about 3 from the end, you had a slide titled Delivery and Installation. It showed up in another place also. Yeah. Could you just tell me what's going on there, please?
On the photo?
Patricia, would you like Floris to describe the equipment that we're seeing?
Yes, please.
Okay.
Oh, all right. Well, this is just showing it's actually myself here on the left hand of the photo. This was a pilot project we did on Long Island. And so this was in the pre-install phase. Normally it's not that difficult, but we helped out with that. And then, you do the commissioning on these units, which can be done by the passive consultant, by the mechanical engineer, or by us, which you ensure that the flows that are designed to end up in certain spaces, for your bathrooms, you normally have like 20 CFM for your kitchens, 25 CFM continuous per US codes. So you balance the system so those flows get there, and then the balancing supply flows are spread out equally or proportionally to your bedroom, your primary or secondary bedrooms, and your living rooms. So so you set the flow rates at the register boxes so that those flows end up in the right places.
Any follow up there, Patricia? Are you good?
No, I'll look into it. Thank you.
Okay, fantastic. Thank you. Well, Floris, it looks like we've gotten through the questions. That was very efficient. And yeah, I don't see any more. I want to give Floris a big thank you for this presentation, and 475 for bringing this new product to North America. And also thank you to everyone for joining us today. Also, just a special shout out to 475 for their support of the Passive House Accelerator as a founding sponsor. They've helped get the Passive House Accelerator going with that support and are sustaining us with that support. So we really, really appreciate that. I think that's it. Floris, is there anything else you'd like to add before we close up?
No, it's very exciting to have this option available for everybody in 2023. That we like to be everywhere very soon, but we can't promise that because we want to be everywhere at the right time and provide good service. So that's a little tricky. But we are committed to that, and so you will be able to enjoy filter fresh air from Brink next year, early next year, and then we hope to hear from you and help you out with your projects.